Let's think now about the domain and range of a composed function. We're going to think primarily about the domain because the range gets trickier. What do we need to do in order to be in the domain of, say, the function f composed with g? When we apply f composed with g, first we apply g, and then we apply f to its output. So to be in the domain of the composed function, we have to be in the domain of g, and then the output of g has to be in the domain of f. And notice that that's not symmetric, which is what we would expect because the composition is not commutative, right? So we would expect the role of g and the role of f in figuring out the domain to be different from each other. So let's do just a simple example where we figure out the domain and range of composed functions where we just have lists of pairs. And then we'll do a slightly more complicated example where our functions are given in terms of equations. In this first example, we want to find the domain and range of k after h. So we're going to apply h first, and then apply k. And when we're looking at pairs like this, I think the easiest way to analyze this is to just kind of follow the functions through. So we'll start in the domain of h, right, where we have -7, 1, 3, and 6. And now h takes -7 to -6. It takes 1 to 1. It takes 3 to 2. And it takes 6 to 1. Right? That's what all of those pairs mean. And now we're in the range of h, which in some sense matches up to the domain of k. Some of these numbers are in the domain of k, right? -6 is in the domain of k. K takes that to -9. 1 is in the domain of k. K takes that to 0. 2 is not in the domain of k, right? -4 and -9 are the other two numbers. So 2 is not in the domain of k. So we're going to just cross that off. And then 1 is still in. K still takes that to 0. Okay, so the numbers that are in the domain of the composed function are the ones that we could actually apply k after h to. So if we want to actually write the composed function, k composed with h takes -7 to -9. It takes 1 to 0, and it takes 6 to 0. Its domain consists of all those numbers that we were able to do the whole composition to. So its domain consists of -7, 1, and 6. And then its range consists of all of the numbers that actually showed up in the output when we followed that through. So its range consists of the numbers -9 and 0. Right? 0 appears twice, but we only need to write it once because repetition doesn't matter to sets. The domain consists of all of the numbers that we were able to follow through. The range consists of all of the outputs that we got when we did that. And that's a straightforward way to figure out the domain and range of a composition when our functions are just given as ordered pairs like this. Next, let's think about what we can do when our functions are given as equations. Here we have two functions, f and g. F is the function square root of x. G is the function 20 minus x with the domain restriction x has to be greater than 0. Right? So we're not going to use the implicit domain of 20 minus x. We're going to use the explicitly given domain x has to be greater than 0. 20 minus x, the implicit domain is all real numbers, but we're only going to use the numbers greater than 0. So the domain of G is given to us. It's x greater than 0. The domain of f, we're told the domain of f is the interval 0 to infinity. So that's x greater than or equal to 0. And that's something that we'll be able to find later in the course, but we're given it now for the sake of the exercise. And we want to find the domain of the composed function f composed with g. Okay, well, to be in the domain of f composed with g, we need to do two things. First, we need to be in the domain of g, right? Because g is the function that's applied first. And we're given what the domain of g is. We're in the domain of g if x is greater than 0. And so that'll be the interval 0 to infinity. What about g of x being in the domain of f? Well, that means that we need to have g of x greater than or equal to 0. Well, g of x is 20 minus x. So we need to have 20 minus x greater than or equal to 0. We know how to solve that. We'll subtract 20 on both sides, negative x greater than or equal to negative 20. We'll divide both sides by negative 1, x less than or equal to positive 20. And so the values of x, such that g of x is in the domain of f, are, let's see, that'll be negative infinity up to 20. So the domain of the composed function, right, that's 0 to infinity, intersect with negative infinity up to 20. This is why we talked about intersections of intervals earlier. So let's just kind of do a quick sketch. The numbers we're interested in are 0 and 20. We have one interval with a closed dot at 20 and everything to the left, another with an open dot at 0 and everything to the right. The intersection is all this stuff in the middle. So the domain of f composed with g is the interval from 0 to 20, where 20 is included but 0 is not.